Right, we're doing chapter 3, which is carbohydrates. And carbohydrates consist of carbon, hydrogen, and oxygen. They're formed by plants via photosynthesis, so we get energy from the sun, water from the ground, and the plants produce starches, which are long chains of carbons. So how do we classify carbohydrates? They are monosaccharides or disaccharides, which are considered simple sugars. Monosaccharides are just one molecule of a sugar, so it's like fructose or it's glucose, galactose. Disaccharides are two sugars, and so lactose is a disaccharide, sucrose is a disaccharide. And then complex carbohydrates, there's oligosaccharides, and those are chains of 3 to 10 sugars, and polysaccharides are chains of sugars that are more than 10 sugars. And as I mentioned before, the monosaccharides, there are hundreds of monosaccharides, which are just single molecules of sugar, but the most common that we talk about are glucose, galactose, and fructose. Fructose and galactose are changed into glucose because glucose is what we use primarily in the body. And then our disaccharides are sucrose, which is glucose and fructose. Lactose is galactose and glucose, and maltose is two glucose molecules. Other complex carbohydrates, the oligosaccharides and the polysaccharides, are just long chains of sugars. Maltodextrin is a filler you commonly see on your labels, and corn syrup is a sugar that we oftentimes see on labels as well. These have been altered for their additive qualities, it could be their shelf life, their taste. So those are common additives added to products. And then polysaccharides are long chains of sugars. Starch is what we find the way sugars are stored in plants, and then glycogen is how we store sugar in animals. Other polysaccharides, fiber is polysaccharide, so starches and fiber are polysaccharides, so there's these long chains of sugar. And their dietary fiber is not digestible, so it's not digested and absorbed in the small intestines. It's passed down to the large intestines, and it just adds bulk to fecal matter. Dietary fiber comes from plant sources, vegetables, fruits, grains, and there's two types. There's soluble and there's insoluble fiber. So soluble just means it's soluble in water. Insoluble means it's not soluble in water. Forms of soluble fiber are oat bran, fruits and vegetables, and then the insoluble is from grains. The insoluble fiber produces more in the fecal matter, adds bulk to fecal matter, and it can't be broken down. So when we talk about fiber, we have naturally occurring fiber in foods that we eat, but then there's also what's called functional fiber. And this also is non-digestible. It also acts in our body as our dietary fiber, but it's commercially produced. And so on labels, you'll see noted dietary fiber plus functional fiber will give you the total fiber. Just a note about fibers, they can help maintain your blood sugar. They can help modify your cholesterol. It's suggested that it might decrease your risk of some forms of cancer, like colon cancer, because as more bulk is added to the food, it stimulates contractions in the intestines to move that food along, and then the idea is that toxins would not be exposed to the cells of the intestines as readily. It has to be used in moderation with athletes because it can leave an athlete with this overly full feeling, or it can cause it can have a laxative effect. Artificial sweeteners, there are non-nutritive or nutritive sweeteners. They're generally altered in some way that increase the sweetness of our regular sucrose, which is our table sugar. They must be approved by the FDA, and they also have what's called this generally recognized as acceptable status. And so the tolerable limits that are set for those are usually very conservative, and they're set well below what's considered even potentially harmful. But artificial sweeteners are not digested and absorbed. They do not provide calories. And so they also can have a laxative effect if they're overly consumed. And this just lists some of the artificial sweeteners. So somebody who's trying to lose weight or make weight, they might be more apt to use some of these artificial sweeteners. But there again, you have to be conservative in your use of them and stay up on research whether or not things are concerned or considered to have a health risk. So carbohydrates are one of our primary sources of energy in our body. For each gram of carbohydrate, we have available to us 4 kilocalories of energy, or that can be used for energy. And it's our primary source of to produce ATP at especially moderate to high intensity efforts. So not as much low intensity, but high intensity, we're almost totally dependent upon carbohydrates. And so if you recall from the energy production, that carbohydrates are in the glycolysis, so that anaerobic energy production where we can produce ATP without oxygen, or carbohydrates can be also used in the oxidative system or the aerobic system where oxygen is available. Also, carbohydrates must be present. They are necessary for us to use fat for energy metabolism. And the other thing about carbohydrates, the more carbohydrates we have available in our body, it's going to prevent changing protein or breaking down protein in our muscle to use that for energy. So when we consume a diet that's adequate in carbohydrates and calories, we'll use that as our energy source, and it prevents us from breaking down the protein. Sometimes when people don't consume enough calories or they don't consume enough carbohydrates, people typically who are trying to lose weight, they're more apt to break down protein. So sometimes when they have that, in an effort to prevent the protein breakdown, they'll encourage people to actually consume more protein when they're following a low carbohydrate to try and prevent that. Carbohydrates also have health benefits. They contain what are called phytochemicals, which are chemicals that determine oftentimes the nature, the texture of fruits and vegetables, and antioxidants, which are disease-fighting chemicals in our body. And so all of these can enhance our immune function and our health. And then carbohydrates, which are very much found in grains, fruits, and vegetables, also contain more soluble and insoluble fiber, also giving us a health benefit. Just talking again about fiber, I mentioned these before, it is believed to lower our cholesterol, our LDL, or our bad cholesterol, and that can reduce our risk of heart disease. It can be disease fighting because of the phytochemicals and the antioxidants that are present in fiber. And it can help us with weight management because it can give us a feeling of being full, and therefore we can actually consume fewer calories because we have this feeling of fullness. When it comes to simple sugars or refined sugars, they don't really have nutritional value, and they very much are related to tooth decay because bacteria acts with the sugars and creates acids, which then can work away at the enamel of our teeth. So sugar has been associated with weight gain, but it's also associated, because of the increased weight, potentially increase a risk for heart disease and diabetes. How much carbohydrate should we take in as athletes? Generally speaking, athletes should consume 3 to 12 grams for every kilogram of body weight, and where on that scale depends on the intensity, the duration that they exercise, the frequency, how many days a week. If they exercise 2 times a day, if they're in a sport that is very much dependent on carbohydrates, as opposed to somebody who's a walker and walks at an easy pace, they're more apt to use more fats, whereas somebody who's maybe a hockey player or soccer, where they're usually using quite high levels of carbohydrates. So it all depends on the season that you're in as well. If you're in training for your competition or your pre-competition where you have to consume a lot of carbohydrates, you're going to be 10 to 12 grams per kilogram, whereas somebody who is more a recreational athlete, they're going to be on the lower end. We can also calculate the carbohydrate intake by taking a percentage of the total daily calories. So if somebody is consuming a 2,000 calorie diet, they would make sure that their carbohydrate intake is somewhere between 45 and 65%. Now, some athletes might even go up to 70 to 75%, and that might be in times when they're intensely training and they have to make sure they're restoring enough carbohydrates or stored form of carbohydrates, which is glycogen. Or somebody who's preparing for a race coming up and they want to really top off their carbohydrate or their glycogen stores. So it's very, it'll vary for each individual. And I have a sample in the file for how you can calculate using these two methods, how many carbohydrates they should consume. Usually you use both of these together to check and see if they both predict you in about the same range.